All right, let's take another look at counting, but this time let's consider what difference order makes. So I have the set A, B, C, D, 4 different letters. We want to take them in groups of 3 at a time. If the order matters, that would be the permutation of 4 things taken 3 at a time, which we could calculate using our formula and get 24. I've also listed out all 24 of those possibilities here in this chart. Well, what difference would it make if I don't care about the order? I just care about the letters that are grouped together. So looking at this first column, it's all the same 3 letters, they're just in different orders. They're all involving A, B, and C. The second column, same 3 letters in that column, just in different orders, A, B, D. The third column is A, D, C in different orders, and the fourth column is B, C, D in different orders. So that, if I group them that way, grouping into just like I care about just the grouping that you're in, I don't care about what order, it turns out we really only have 4 distinct groups. Or the mathematical term is 4 distinct combinations of those. A combination is when we are taking a group of things and we don't care about the order, but we also don't repeat anything. So it has that in similarity with a permutation. We still don't reuse things, but this time I don't care what order. I pick 3 people to be a team to represent us. We don't care who was picked first, second, and third. They're not getting prizes. So when the order doesn't matter, what we're talking about is a combination. In another video, we'll take a look at the formula for calculating that. In this one, I just want to look at, is it a permutation or a combination? Again, the difference is, does order matter? So the first situation we have here, 50 people purchase raffle tickets. 3 winning tickets are selected at random and awarded. If we have $100 for the first prize, $50 for the second prize, and $25 for the third prize, well, does it matter what order we're talking about? Oh, yes, it does, because I would rather get that first prize than the third prize, right? So the first one here is going to be a permutation, whereas the second one, hey, you got chosen, you get an Amazon card. Doesn't matter if you were chosen first, second, or third, that's a combination. All right, so hopefully that makes sense. Take a look at the next one with the 30 students and see if you can figure out which one's the permutation and which would be a combination. Okay, let's see how we did. So 30 students in a class. It says 4 are chosen to go on a field trip. They're all going. They all get in the same vehicle. They go to the field trip. So the order doesn't matter. That would be a combination. On the other hand, if I'm going to select officers for the class of president, vice president, and secretary, then yes, it does matter who gets what position, because if John is secretary versus John is president, that's 2 different types of things, right? So order would matter here. That would be a permutation.